produced the same number of watts.
1929年呢，这个哈勃有了全世界最大的望远镜。那他当时的假设就是说，全世界所有的亮星呢，这个亮度都是一样的。
And what he found was remarkable, that the larger the redshift of the galaxy, that's the faster it's moving away, the fainter the stars were.
那他发现的东西很重要。他说，当这个红移越大的时候，它远离我们的速度就越快。
And so that meant those galaxies were further in distance. And with that information, he proclaimed that the universe was expanding.
那离我们越快，也就是那个星球呢离我们越远，因此他得出一个结论：宇宙正在膨胀。
Now, it may not be obvious to you why that is.
那也许大家觉得这样还听不出个所以然来。
But first, let me show you Hubble's data.
但是我现在先让大家看这张图吧。
So this is the data Hubble published in 1929. This is nearby.
这个是哈勃在1929年的图表，它指的这一点呢，就是靠近我们的地方。
And this is far away.
那这个是远离我们的地方。
At least to Hubble, it's not so far anymore.
好，那就是这边远，这边近，这边远，这样子。
And this is how fast the galaxies are moving away. This is not moving at all.
它现在红笔点的这边呢，就是星系完全没有远离我们。
And this is moving about 1,000 kilometers per second.
那最上面就是以每秒1000公里的速度远离我们。
I think Hubble's data looks messy.
我个人认为呢，哈勃这个观测资料还蛮一团乱的。
But he is very famous.
不过因为他很有名，
And so I hope when you see my data,
所以我想你们等一下看到我自己的观测资料的话，
you will think I should be famous too.
你们也觉得我应该很有名。
So here is how to understand Hubble's observations with a toy model of the universe, which I can expand.
好，我们现在用一个玩具版的宇宙来了解哈勃眼里的这个所谓的膨胀的宇宙，这个宇宙。
So here I expand the universe by 5%, and I overlay the before and after.
我把这个宇宙呢膨胀5%，然后我把膨胀前跟膨胀后的影像重叠在一起。
And you can see from this point that nearby objects have moved a little bit when I've expanded the universe. They're moving slowly, and the distant objects have moved a lot. They're moving quickly.
好，在这个画面大概中间左上这个地方呢，你可以发现，如果以它为中心点的话，附近的这个星球呢，它扩张的没有那么大。但是如果到右下角啊，很远，它的这个远离的距离就变得很大。
This is exactly what Hubble saw.
那这个就是
The further an object is, the faster it's moving.
哈勃看到就是这样。当一个物体离我们越远的时候，它远离的速度就越快。
And the beauty of this is it's not just this person, it's any person. I have taken the same images and just slid them over to a different point.
那这个好玩的地方就在于说，不管你从哪一个点进行观测，看到的结果都会一样。比如说，如果把中央点移到这个右边这边来的话，你看到的也是离你越近的扩张越小，离你越远的就是离你这个扩张的速度越来越快。
The Earth, once again, is not in a special place in the universe.
那再次的，地球不是特别的地方。
So, it turns out that Einstein's theory of gravity explains and predicted, even though Einstein didn't really realize this, that the universe should be expanding. He actually realized it, but he didn't think the universe was expanding, so he fudged his equations to make the expansion go away.
那这样子看起来，其实爱因斯坦的这个重力理论其实是有道理的。 爱因斯坦在世的时候，他不认为说他自己导出来的广义相对论会造成宇宙应该要扩张这种结论，所以他稍微给他微调一点。但现在看起来，其实他当初这个重力理论是有道理的。
Einstein's theory of gravity is the most elegant theory in physics today, and it too was shown to be correct by observations of the sky.
爱因斯坦的重力理论呢，在今天仍然是非常精密了不起的物理理论。那即便从这个天文学观测的角度来看，他的这个理论也是相当的重要，有影响力。
Einstein's theory predicted that light would be bent by gravity, and this effect was seen in an eclipse of the sun by the stars behind the sun.
他预测到说，这个光会受到重力而这个弯曲，那这个我们可以看到从日食的现象可以发现得出来。
And so we have observations and theory, and those, when you have both of them working together, you think you understand the universe.
我们一边有观测，一边有理论的学说，当两者结合在一起的时候，我们就有个方法可以去了解宇宙了。
So when we look at an object in the expanding universe, we look back in time.
好，我们现在看这个扩张的宇宙，我们往回看。
And when light travels to us, light is a wave. And as it travels through Einstein's expanding universe,
光从遥远的过去向我们走来，那它是沿着这个爱因斯坦的这个扩张的宇宙这个走过来的。
the light wave gets stretched. It starts off as a blue light wave, which goes up and down quickly, and that light gets stretched redder and redder, which means longer and longer.
那这个光以波的形式过来，当它是一开始的时候，它是比较偏蓝的，它的频率比较高。但是当它越来越走，它的波长就变得越来越大，颜色就往红色的方向偏移。
The objects are not moving away from us. It's actually that space is being created between us.
这样子说来，这个宇宙呢是在我们之间去做扩张的。
So the universe is expanding. What happens if we look what happens if we put it in reverse?
那我们现在知道宇宙是在扩张，但是如果把它倒回来看，会发生什么样的状况呢？
Naturally, everything in the past at some point is top of itself. That's the time of bang.
很自然的，如果东西扩张，在过去某一个时点，它必然所有的东西都互相重叠在一起，那就是我们的大辟。
So let me run the universe in reverse for you. Here we have right now two objects separated now by a certain distance.
好，现在我们来看，这边中间红点是晒，那纵轴呢是两个物体、两个星系之间的距离，横轴是时间。
If on the universe in reverse, the objects get closer and closer and closer until on top of each other.
如果你现在这一点倒回去宇宙最初起源，你会发现到这个最下面这边的时候，所有东西都是互相重在一起的。
So that is the time of the Big Bang.
而那就是大霹雳。
So we call the rate that the universe expands the Hubble constant in honor of Hubble.
那我们扩张的速度称为哈勃常数，来纪念哈勃。
And it tells us how old the universe is.
而且透过哈勃常数，我们可以了解宇宙的年龄。
These are astronomers' units, but the units you care about is how old the universe is. And we think the answer is that the universe is about 14 billion years old.
图表上看到很多都是天文上相关的数字，但是我们想要真正知道的是宇宙到底有多少岁。那我们认为现在哈勃常数大概是在70这边，所以这样推过来，宇宙的年龄是141亿年。
So how fast the universe is expanding tells us how old the universe is, but what happens